In this video, we're going to go ahead and introduce those trigonometric functions that you're so fond of. There's actually 6 of them: sine, cosine, tangent, secant, cosecant, and cotangent. 6 of them. So we're going to dive into where do they come from and how are they going to help us in trigonometry, right? Okay, that's all you really care about. So to begin, let's go ahead and look at where do these functions come from. So we need to look at a triangle. That's where they come from. So here we have a drawing. You see we have the angle theta, and what's happened is it's created this nice triangle. Okay, this nice right triangle. And some things about the triangle that you should note is that on the ray with ending theta, okay, with the angle that ends in theta, you have a point, and this point is xy. Now, you can go ahead and pick any point you want to, but it'll end here. And it'll have some generic forms. And the first thing you should note is that this triangle has 2 legs. The first leg has a width of x, right, because that's how long it is, x. And then how tall it would be y. And then there's one final side of this triangle, and that would be the hypotenuse. And the hypotenuse has the length of r. Now, x and y are given because you'll be given that point. But what about r? How are we going to find r? Well, you could actually use the distance formula if you wanted to. And the distance formula, if you remembered, is the square root, I should probably use my board for this, of x1 minus x2 squared plus y1 minus y2, throw a little minus in there, squared. But since our points are x comma y and 0, 0, which is pretty awesome, that's just going to fall off. That's going to fall off because it's 0, right? Subtracting 0 does nothing. So basically what you're going to get here is the square root of x squared plus y squared is going to be the distance from this point to that point, or what we would call r. So it all comes from the same place. You could also figure it out using Pythagorean theorem, which we'll talk about in a later video. So just be on the lookout for that. So this is basically the triangle that we're going to use to help us create our trigonometric functions. So this is just where it comes from. So there's our r equals square root of x squared plus y squared formula. We're just going to tuck that away for use in just a little bit. So let's go ahead and clean this up. There we go. So here are the 6 trigonometric functions of theta, or just any angle that you measure. Okay, Greek letter theta represents an angle. So here's our triangle again that we're using. So over here you see the first one is sine of theta equals y over r. Now you may have learned it as sine equals opposite over hypotenuse. You may have learned the old SOHCAHTOA. That I spelled wrong. We're going to pretend that was an H. I know how to spell. Okay, so sine of y over r, so opposite over hypotenuse. That's the same one. And then cosine of theta is x over r, which you may have remembered as adjacent over hypotenuse. Maybe I should really learn how to spell today. I'm just going to fix this real quick, and we're just going to pretend that it was not that the whole time. Look at it. Yay! Okay. So cosine of theta is adjacent over hypotenuse. Adjacent over hypotenuse. And tangent of theta is y over x, which is opposite over adjacent. That's how you'll figure out tangent. And these 3, sine, cosine, and tangent, are your main trigonometric functions. These are probably the ones you're most familiar with and most comfortable with. These are the ones we use the most because their opposite functions are actually just the flipped, the reciprocal of those functions, 1 over sine. So cosecant is 1 over sine because you can tell because the fraction is just flipped, right? Now we have the hypotenuse divided by the opposite, the length of the opposite side, and secant is 1 over cosine. You can write that there, cosine theta. This was 1 over sine theta. And cotangent is just 1 over tangent. I think that one's the easiest to remember because cotangent, just flip the top and bottom. So those are your basic trig functions, and we're going to go ahead and use those to come up to calculate some values. So let's get right to that. Okay, so you can see here I've given you your 6 trigonometric functions that we're going to use. Here's your basic triangle to kind of see what's going on. And we have a problem that says the terminal side of an angle, theta, in standard position passes through the point 7, 10. So they give you that point that we need. And they want you to find the values of the 6 trigonometric functions. Why don't we go ahead and just draw a triangle to help us visualize what's going on? Doesn't hurt, right? 7, 10. So that's going to be in quadrant 1 because they're both positive. So you're going to go over 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why didn't I pick smaller numbers? I don't know. I could have made this problem anything I wanted. I thought I would make it exciting. There you go. Okay, now let's make that triangle. So this time, since it's in quadrant 1, it's going to look like this. Here's our nice right angle. Now this was the point 7, 10. Boom. Now we want the length of the leg over here. Well, the length of the leg is going to be x. How many spots did we go on x? Well, that's just 7. And then the other leg is going to be 10 because that's just our y value. Now this r, how are we going to find that r? Well, if you remember, we had that formula we talked about earlier, and we found it by using the distance formula. So r was equal to the square root of 7 squared plus 10 squared. So we just need to simplify that. We get 49 plus 100, which is a lovely 149. Which does not simplify, so we're going to go ahead and just leave it as square root of 149. That will be our r. So, oops, let's get a pen here. Somehow I skipped to the next one, did not mean to do that. Let's go back. Okay, there we go. We're all good. Now, so we have the square root, we have the size, the length of r, and we need to go ahead and actually find the values of the 6 trigonometric functions. That's what they want us to do. So let's jump right into it. Let's start with sine. Sine of the angle theta, this would be the angle theta. Okay, it's going to be equal to y, which is 10 over square root of 149. Now we could go ahead and simplify that top and bottom by 149, and so we could rationalize the denominator, but to save time, you can just do that on your own. Okay, let's go ahead and just do cosecant because they're opposites of one another, right? So it should be easy. We just flip the fraction. 149 over 10. Don't even have to rationalize the denominator there. It's already done for us. Okay, let's move on to cosine of theta. Cosine of theta, if we look at the formula, is x divided by r. So x is 7. R is square root of 149. Again, you'd probably want to rationalize the denominator there. But to save time, we're going to go ahead and just jump secant. This is now r over x, so we just flip cosine. And boom, we've got our secant, okay, function. And last but not least, let's do tangent and cotangent. Tangent is y over x, so 10 over 7, opposite over adjacent. And cotangent of theta is x over y, so we just flip that fraction, 7/10. And we have our 6 trigonometric functions. And that's basically how you find, given a point, how do I find those 6 trigonometric functions? As long as you can figure out that r, you've got all your information you need, and you just plug it right in and go to town. So good luck, and I will see you again soon.